Okay, welcome to the first video of the 8th week. So we're still in chapter 12, but now we're moving on from exponential smoothing, moving averages, stuff like that, and now we're getting into trend analysis. How do we forecast a time series data set when we have a trend? So as I mentioned before, whenever you have time series data, step one is graph it. And I know I've already graphed this, but I still want to do it again. So I'll graph this and move the chart. And then, of course, I want to insert my trend line. And I'll make that big so that you can see it. Okay. All right, there you go. Okay. So clearly, these are those bicycle sales, and we've already looked at this. But the point is, you graphed it, you see an upward trend in this case. Well, the point is, right away, the forecasting techniques that we learned previously no longer apply here, right? If you think about using the naive forecast, well, if I use last period sales to forecast the next period, I know right away that my error is going to be large because I have this upward sloping trend, right? So automatically I know that next period sales are more likely to be higher than, next period sales are going to be higher than the previous period sales because I have this upward trend in my data. So already the naive forecast is lost. Same thing with the moving average and the weighted moving average, right? So if you think about like a 3-period moving average, well, then I'm taking the data for these 3 periods and averaging them out when, in fact, I know that I've got that upward trend. So again, my forecast, a 3-period moving forecast, is likely to underestimate the next period's sales because it's not taking into account the trend that will be exhibited in the 4th, 5th, 6th period, right? And then the same thing is true of the exponential smoothing. I mean, by definition, the exponential smoothing is trying to smooth out your time series, right? Because you think that, there is no trend. And so it's trying to smooth out all those fluctuations. Well, I don't want it to smooth that out because I have an upward trend. So those 3 forecasting tools are out the door. We have to come up with something new, and that is the regression line, right? Or time series regression. And so that's what I've got here. So here is our regression equation. So y hat t, this is going to be our predicted sales. And then beta naught, this guy right here, this is our intercept. And then beta 1, that's going to be our slope. And then t is going to be our time parameter. So that's what this is. You have time period 1, time period 2, time period 3, so on and so forth. All right. Now, as it turns out, one of the reasons that I always wanted you to graph it is this is an equation of a straight line. It turns out that that equation is the equation of your trend line. That's why I always encourage students to, graph your time series data and then include a trend line, because this trend line is this equation. Now we have to put some numbers, what is the intercept, what is the slope, so on and so forth. We have to calculate that, and I'm going to show you how to do that in just a minute, but that's it. And then the difference between our observed sales and our predicted sales is what we call the error or the residual. And that will come up in just a minute, because as we did before, we're going to square that error and take the average of that squared error, and that's going to give us a measure of how good this trend, regression line or trend, allowed us to predict period 11 sales. So just real quick, I know this is going to be hard for you guys to see on the video, but nonetheless, bear with me. If I go into Chart Tools and go to Design, and then go to Add Chart Element, go to Trend Line, and then here, where it says More Trend Line Options, you can hit this box that says Display Equation on Chart. This is actually that regression equation. and I don't think I can, no. Nope, sorry. I don't think I can make this bigger. My apologies. But hopefully you can see it. So this says that y equals 1.1x plus 20.4. Well, this 20.4 is the y-intercept. So if I could just imagine this line coming out, it would intersect here at 20.4. And then the slope of this line is 1.1 units. So these sales are in thousands, so that would be 1,100 units of bicycles per time period, right? Because the slope, this is just the slope of a line, so it's just the rise over run. Don't make this any more confused than it has to be, all right? Now, I'm going to show you how to get this equation in just a moment. You don't want to do what I just did. I'm just doing this to show you the link. This equation right here is the regression equation, all right? Now, I'm going to show you how we get this in a more formal setting, but I wanted you to see and kind of link all this stuff up. That's why I've been telling you, put in the trend line, okay? So, with all that said, how do we get our, the equation for this regression? So your book goes through what I think is a very odd way to do it. You don't have to do all the calculations that your book has done. In fact, if you read the book at the very end, on page 761, the author does tell you that there are these software programs like Excel that will calculate the regression equation for you. So you don't have to do it manually like your book did. So let's see how to do that. So what you want to do is you want to go into data, and you want to go into data analysis, and then go down to regression and hit OK. So your y or your dependent variable in this case is going to be sales, right? The x variable or the independent variable is always going to be time. In this case, it's going to be the year. So here's my y range. Highlight my x range, or my time, right? That's what the T here stands for, time. So this is time period 1, time period 2, time period 3, so on and so forth. That is always my x range. And then, of course, I included my labels. And then what I want you to do is hit this box, residuals. That's this. Excel is going to calculate those errors for you. So you're not going to, we're going to have to do is square them and take the average, and presto, we're going to be done. So, to recap, your y variable is, in this case, your sales. Your x variable is always your time period. So whether this is years, quarters, months, or days, that's always going to be your x variable. And your x's always have to start at 1 and then go up to however much data you have, right? So if we had 50 years of data, you'd start at 1 and go to 50, okay? All right, so with that said, we're now ready. Hit OK, and Excel is going to put this into a new worksheet for us, which we're thankful for. So I'll make this a little bit bigger. Now, a lot of the information here, you guys don't need, right? So the truth is, some of this stuff, all this stuff up here, is beyond the scope of this class. We are going to be dealing with this stuff down here, the residual output. So let me make, oh rats. Okay, let me make this a little bit bigger so it's easier for you to see. Okay, so here we have our time period, right? Observation 1, 2, 3, so on and so forth. Here are our predicted sales. So to help you see this, that would be the predicted sales are on the regression line itself or the trend line. So even though we can't see this because I've blown everything up, there's a small gap here between our actual sales and our predicted sales. And in fact, that gap is equal to 0.1. And actually, I can show this to you because here are my actual sales. So if I just go over here and copy this here and hit paste, here's the point one, right? Because this is what I was trying to get at in this equation. Your residual or your error is just your actual sales, these numbers, right, or this number. Well, I lost my cursor, right? Here is the predicted sale for time period 1. Here's the actual sale. And of course, 21.6 minus 21.5 gives me my residual or my error of 0.1. And you can see all this. This is the data that's on page 760 in table 1512. So as you read through the text and watch this video, know that you don't have to go through and manually do all those calculations. We're going to use Excel's regression function. And make sure you hit that box for residuals so that Excel can, provide them for you. There's no reason for you to calculate any of these. Okay, so just real quick, so that we're clear, how did Excel get these predicted sales? Well, it used the equation of that line. So for example, in time period 1, right, we're going to have the intercept plus the slope times time period 1. Hit enter. There is your 21.5. Right, and your book talks about how to do that. I'm just simply pointing out that why do it by hand when Excel will do it for you, okay? So that's how Excel calculated all of these predicted sales, and then Excel was kind enough to say, okay, I know what the actual data is, so I will subtract the predicted sales from the actual sales and get your residuals. All right? So Excel, the point is, Excel is doing everything for us. The only thing we really need to do is, I want to get rid of this real quick, is we need to kind of calculate, well, how good of a prediction is this model, right? How good is this trend line or this regression line? How well does it predict our sales? And so again, what we're doing here is we're using our trend line to predict these sales from month 1 to month 10. Now, yes, these have already occurred, but again, I want to compare what my model predicts for these time periods versus what actually happened, so that I can calculate how good my model is doing. And of course, your book talks about this, and we've talked about this before. The best is the mean squared error. Now, in this case, the residuals are our errors, so all you're going to do is square your residuals. So I'll square all these, right? And then, as we did before, take their average. So let me try to keep all this on one page for you. So I'll just, I'll calculate the average here. Okay, so we have an average of 3.07, but as I mentioned before, right, this is the squared residuals, right? I personally think it's better to take the square root of this, right? This is, in my opinion, this is a much better estimate of how far we think we're going to be off, right? So, the point is, this is actually pretty good, right? Because these sales are in thousands, and we're only the error here is about 1.75 thousandths, right? So, not too bad. Because see, some of these residuals, here's 1.8, negative 2.9, negative 2, 3.4, negative 1.7, right? So some of these are off by a little bit, right? But then, of course, we get some really close ones, like a 0.5, a 0.5, a 0.3, and a 0.1. Well, the 0.1, that means you're only off by 100 units, right? Because everything's in thousands. So the point being, this appears to be a fairly, good number in terms of the error. And then all we have to do is to predict time period 11's sales, is use our regression equation. So just like I did before. So we're going to predict period 11, right? So based on our trend model, we're going to take the intercept plus our slope of 1.11 times time period 11. And there you go. So based on knowing that we have a trend, we would predict that time period, year 11, right? Time period of year 11, that the bicycle sales in that year would be about 32,500, and we know we've got some error here, and so we could be, down as far as 1.75 or up as much as 1.75, right? That would set my error bounds, all right? Now notice that this is in my opinion, a much better predictor of, say, the naive value, right? The naive value would say period 11 sales are 31.4. And see, this is my point. That naive forecasting method doesn't even take into account the trend. You could have done a 3-month or 3-year moving average, right? So average, right, last 3 periods. It's even worse, 30.3, right? Again, you see what's happening is I'm averaging all these bicycle sales, right, before, how do I say this? See, these are always, generally speaking, these bicycle sales in periods 8, 9, and 10 are going to be less than the predicted sales in period 11 because of that trend. Now you can see that the trend is there, and the average, in a sense, is picking up the trend, but you're taking into account with the average, moving average, you're taking into account something that happened 3 time periods ago, right? And so our trend is 1.1, so if you multiply that by 3, you get 3.3, so you would expect, take this number and add 3.3 to it. That would be a better way to go, right, than just taking the average of all of these. So, bottom line, that's why we use this regression analysis and this time trend, because it gives us a much better prediction in the period that we want to forecast. Now, like before, I'm pretty sure I said this before, my recommendation is only to forecast out 1 or 2 time periods. It turns out, like I was mentioning before, it turns out that your error bounds can grow the farther out you forecast things, all right? So it's only really safe to maybe forecast 1 or 2 time periods. Yes, some people have gone out more, but you're starting to, the accuracy of that forecast is decreasing substantially the farther out you forecast. So just forecast out 1 or 2 periods. So let me get rid of that. So I feel comfortable forecasting out 2 periods here. So I would just take, again, my intercept plus my slope times the number of time periods, and there you go, right? So intercept plus slope times the time period that I'm trying to forecast, and that would give me my forecasted sales for period 12, and you can see that they're just 1.1 units higher than the period 11 forecast. Okay, lastly, actually I think that's it. So I've got my residual. So the residual, I didn't want to show you this. The residual is the difference between your actual and your forecast. And so that's this distance here, right? This vertical distance here between my actual and my forecast, that would be a residual. Here's another residual, right? This vertical distance here is a residual. Here's a residual. Here's a residual. Now some of these others, right, here's where I had those very small residuals, right? Like this one here is 0.1. In time period 2, I think the residual is 0.3. Yeah, 0.3. And that's why these things are so close, right? That's why the trend line is so close to the actual sales for that period. But at any rate, I've kind of motored on a little bit longer than I wanted to. I apologize for that. But I want to make sure we got everything. But there you go. That's how easy it is to forecast time series data. when you have identified a trend. And then I do want to leave you with one last thing. Statistically speaking, I know that this is valid because this T-stat, you guys might remember from your statistics course, right? A T-stat of 5 means that this coefficient is statistically significant. So in fact, I actually do have a statistically meaningful trend. And for those of you that maybe don't remember, they call this the easiest way to know if you have a statistically significant trend is they use the rule of 2. So if your T-stat is greater than 2 for a positive trend, or less than a -2 for a downward sloping trend, then your coefficient here is what we say is statistically significant. In other words, you actually do have a trend, right? This is not a flat line, okay? So that's not in the book, but just so you know, this tells me that indeed I actually have a valid trend here. Okay, well that's it for this video. Just 2 more to go.